Hello everyone. Today I will be making a little bit longer video, and before I start I have to say that the inspiration for this video I have got by watching a great video from Andrei Karpathy around LLM models. And if you really have time, please watch that. It's quite long, about 3.5 hours, and no worries, mine not going to be that long. But that video, it's really worth every single minute that you're gonna watch that. That's this one here, and I will post in the comments of this video. I will be actually also posting that video as well, so please have a look if you have time. Okay, so what we're gonna show today is the interworking of the Waylay Multi-Agent Studio. And I will go step by step to explain how we actually build these applications, how we use the LLM, and what are the additional things we've done in Waylay to make the use of the agentic applications as easy as possible. So in order to do that, let me start with the end product, if you like. It's that one of the agentic applications or the bots where I will be using as example something like, okay, I want to do the analysis of the HX, given that I can measure some telemetry parameters for a given asset. And that's what we are seeing here. We are looking at a particular set of HX. I can do something like run me diagnostic test for HVAC1, and eventually we'll be creating the uh, diagnostic tests. We'll be looking at what is missing in case that there is a problem with the given HVAC, so there is no alarm triggered here, so everything looks good. But I can also do some what if scenarios, so something like do the same test if the airflow is 800, temperature 80, and the energy usage 6. Then you're gonna see alarm being triggered. It's gonna point to a problem with the filter. Then I can say something like show me the inventory, and so forth and so forth. Find a spare part for a given problem, create me a work order. So this is one of many different applications that you can create based on our technology. So how we have done that is that we use the Waylay Studio to create these applications. That's what I'm going to be showcasing today. But before that, let me start with a mind map of how I'm going to do this complete video. So, like I said, I will be focusing on building the applications. That's what we see here. But before that, I need to introduce quite a few concepts that some people are not maybe familiar with. First of all, one thing that we know as we use ChatGPT, for instance, is that we are running the so-called LLM models. There is some bit kind of an assistant API layer on top of that. Every model, as you know, comes with set of weights and inference. And the LLM works that way that each of the knowledge that we summarize over time, whether it's going to be a book or a web, it's tokenized. There are around 100,000 unique tokens, and everything that you put, like even mathematical formula or a question, is going to be tokenized. And like Andre was showing, this is a good way to actually check what is happening. So if it says show me data for HVAC1 and do the do the test, you will basically see that each of these things is going to be represented as a set of tokens. This is what we mean then by seeing a token count. And this is going to be then sent towards the LLM, yeah, in that context window, if you like. And this is basically what's happening. We'll be sending this stuff around. But the other thing that the LLMs do is that they have something called a prompt. And there are two sort of a system prompts. One is kind of something which is embedded inside the model itself, which we normally do not see. And there is a lot of conversation around what kind of, if you like, root system prompts are in there. So for instance, in order to avoid giving some answers, which are tricky, or to defend a user from offensive material, so to speak. And what you do then, basically, it's to kind of overlay that with your own prompt, which is basically a role that this assistant will be taking when it starts answering your questions. Now, what does it mean? It's that if I go to ChatGPT, and ask the question, do me 2 plus 2, yeah, it's going to present it as a set of tokens and you're going to answer that straight from the LLM itself. So sometimes this can be tricky because sometimes LLMs are not good in maths because don't forget each of these numbers will be shown as a set of tokens. Yeah? Now, if I do something like this, do me 2 plus 2 using code, something else is going to happen. The LLM is going to take this string, figure out what is the input argument for the tool, and it's going to execute a tool such as something like a Python code. And if you just say now execute that, it's going to execute this tool to do the to do that mathematical computation. Yeah. And here you're going to see a result. So this time it was not LLM who has decided to compute 2 plus 2 to 4. It delegated that to another tool to actually do the right execution. And this is where the tools come in place, is that not only that we can have the set of scenario which the LLM is going to answer, but we also can make use of tools to delegate some of this execution to someone else, someone who knows things better. And that's basically what multi-agent things is about. You delegate execution, but what the LLM has to do is to know how to marshal the input arguments and delegate that to someone else. Now, that's something else, can be an API endpoint, can be a flow, can be a rule, can be an ML or any other thing. What is important to know is that each of these toolings have to have a couple of things such that LLM knows its capability. That is, what is the name of this thing, what it can do, like a description, and what are the input arguments. If it's a text, that's kind of easy. But if you say something like, what's the weather in London, then I need to know location. I have to tell LLM, I need location. Figure it out from the input how to give it to me. Now, one thing which is interesting is that you not normally have to explain to LLM what is the output. That's kind of interesting, and I'll come back to that later. Because if you use the APIs in the flow, you really have to know the output because you have to pass that output to someone else to do some other things. Here things are a little bit different. And you will see how we use our APIs to be able to be executed as inside the flows or inside the LLM without any code change. That's a very interesting thing to just mention here. The other thing that I would just like to mention, because I get often the question, do we need anything else than LLM for the reasoning or as for decisions? Now, the thing is that LLMs can make decisions, and this is what we do in assistant applications. Having said that, as I already mentioned before, sometimes you want to delegate some other things, including maybe reasoning, to someone else. Now, if you look at the typical problem in the IoT world when you want to do diagnostic of the given HVAC, you do not necessarily want to delegate to LLM everything. That is to say, here is the data, here is the problem, figure out what the issue is. For that, you always need the labeled data sets with the problems anyway. But I just want to say that, as been proven many times, LLMs are not necessarily good in maths. They're getting better, but not necessarily always good. Because do not forget that every LLM, in essence, it's working on top of the tokens, including the numbers and functions and all other things. So what does it mean? Is that every n-dimensional space, you're squeezing in one space, one-dimensional space of tokens. Now, if you look at something like a data, like for instance, for the HVACs, you might have 3-4 different things. So now you can say, okay, I'm going to use rule for that, or I'm going to use a machine learning model, doesn't really matter, but you will be working in the n-dimensional space with labeled data sets, trying to figure out what the issue is. So give you example, if you work on anomaly detections, you can use machine learning models to give you something like, okay, there is an anomaly here. But if you want to say what's the actual problem, you still don't know unless you do the pattern matching for a given problem. So this becomes immediately pattern matching problem or a rules problem of combination of these two. And that's also very important to understand. The second thing that I often get as a question, which is kind of interesting and funny at the same time, can I use the neural networks to do the same thing? Of course you can, because in that context of the anomaly detection or a pattern matching, neural network models are behaving, rather not behaving, they're doing exactly the same role as if you do the classical ML, because they work on the multidimensional data sets, being multimodal. That's often what people talk about now with the neural networks. But please do not forget, they work in a different space. It might be that you're transforming that to another n-dimensional space. You might work with the reduction of the spaces, but you work with the numbers, with coefficients. You're not working with one-dimensional set of tokens. So for instance, if you use sequence to sequence for a time series analysis, yes, you're using neural networks, but you're not using that on top of tokens. You're working with this model on top of n-dimensional data sets. So what I want to say is that if you want to delegate a computation like image processing, video processing, signal processing, or anomaly detection or pattern matching, you normally do not use LLMs for that. But it doesn't mean that LLMs cannot make use of this through the tools. So that's a very important thing to say. Now, when the result comes back from the tool, it's going to come in something like a JSON or XML or text or any of this sort. So that thing has to go back into the answer here to the LLM, and that this response it's taken back to the calling function or to calling application. Now the interesting here there is that it can't go through the tokenizer. Then it does dynamic translation to any language, it doesn't matter, and you get response back. Now, one thing I want to say is that for the time being, these responses are kind of a text, kind of a markdown text. There is something now which is like a JSON schema responses that enables you something to know upfront what kind of schema, what kind of model of a response you're going to get back. Without that, it's hard to make a widget on top of that if this is not controlled. Yeah? But now for the time being, let's imagine that this API response is going to be again massaged, if you like, through the LLM and presented to you or application that you can actually then use. And finally, before we give a demo, and then we go again through each of these little um, uh, parts of this story, let's not forget that there is also something called the context window. What does it mean? It's a kind of a short memory. So when you ask questions and answers, the next answer will depend on the previous questions and answer you have asked the LLM. That's what we call a memory or a context window, and that's what we sometimes call, like in our case, a session. Session is something that the LLM will take into account, or rather that memory, as you're going to be asking the following questions. The same things happen if you like in ChatGPT, even though sometimes ChatGPT is smart enough to know, okay, this is a totally new question, totally new domain. So I'm just going to flash my memory, keep it somewhere else, and start a new conversation. Because the context of the conversation does not make any more sense to someone who is asking something totally new. So now with that, let me just now look at how we are actually building this application. And like I said, this is going to be a little bit longer window. So I started my presentation by giving you right away the application. But let's start from the beginning and see how we actually create such an applications. As I said, we'll be starting from the API endpoints. Now, what does it mean basically? Is that if I ask, let's say classical thing like give me a weather, this is typically what people often use in the examples, I can have an API call for a given city to get back the answer. Yeah, so I'm gonna just run that through our API. And if I test that, I will get back temperature and other things. Now notice here that I had both the inputs defined and the outcomes. Now, the interesting stuff that LLM will only care, if you like, at very beginning about these things rather than the outputs, because outputs will be given and then it will be using that in a kind of a sequential way. It doesn't care too much about the bigger picture. It takes one problem at a time and split it and do sequentially things one at a time. Yeah? That's also very interesting about the reasoning using this. Now, if you want to use the flow, forget about the LLM. What you're going to do then, I can show here, is that you have something like this. Sorry, so I think I took the wrong one. Do I have it here? Yes, so this one here. This is a typical flow, or if you like, the final state machine doesn't really matter. The things that actually it's completely deterministic. I am taking the city as input variable. These are my outputs. And then here what I'm going to say is that is the temperature above zero? And then I'm going to just say, well, if that's the case, I'm going to put in Slack message here, it's freezing outside. So if I just do that, let me just remove the other node just that we have a little less of a things in here. And this is what's going to happen. So here you see true, it's not freezing, but I'm going to post that message of the current weather to my Slack. So this is what has happened. So I've done a lot of things at the same time. And please remember that in order here to know whether it was freezing or not, I had to know what was the output of what were the provided arguments, not only for input, but also what this thing is producing. Yeah? Now, the thing is that if I want now to make an application that just use the current weather, so what I can do is to take this thing in here. So where is my weather? That's here. I'm sorry, I'm in the wrong place. So that was the weather here. Get the current weather. I'm going to take now the system prompt. It's going to be just one that says, okay, I will take a default one, change that, and I'm just going to say, you are the agent that can answer the question about the current weather. Here, what I can do now is I can hide some of the input arguments such that they are not visible to the LLM. So it will only know that the only thing I need to know is city. Yeah? So if I now deploy this application, so here I can also change but I'm not going to do that. I can change also the function name. Now, when I deploy this application, what has happened is that looking back here, I have taken only one API from here, created the role prompt, you can answer this question, and now the LLM will know if I'm asking anything about the weather, it's going to delegate to this tool, similar to what I have doing with the ChatGPT saying, okay, use the code to compute 2 plus 2, and it will give me the answer in real time. So that's what has happened. Now, if I test that and I just say, what is the weather in Paris? So here is what's going to happen. I'm just going to take one more tab here because I want to actually track this session in real time. So this was my application which I have just built. So let's wait for a second. I had just one little guy here. That's this guy here. And I have sessions. So here, see what was the weather in Paris. It has invoked the tool that gave this as a result and then gave me the answer. The current weather in Paris is this. Yeah? So this is what has happened. I had only one API and delegated that call to the other tool to answer that question. And that's all. Now, if I want to create a more sophisticated application, I can start adding more things. So let me just now go back to the demo which I was showing here. How I have created this application for a CRM application. The first thing I needed was my diagnostic test. Now, one thing that we can also do is that each of these flows, so let me show you one that I have here. I can do more deterministic tests. I could have also used the machine learning for that. That says that given the HVAC that I have in mind and energy usage, again, I'm using the same example 6, the current temperature 80, with the airflow 600, if I run that, you will see that they're all above a threshold, and because of that, I have actually fired a filter issue. So what I'm going to do now, I'm just going to expose that as a tool. So I'm exposing the diagnostic template, a rule, which is going to look in another data sets, and that's going to be then used anytime the LLM sees, okay, run me diagnostic test for HVAC, is going to actually delegate the execution and root cause analysis to an API, which is hidden behind it has the rule, and it's going to come back with a filter problem, yes or no. Again, what I'm doing now here is that I'm exposing the rule here that needs a data set to tell me if there is an HVAC problem or not. But now remember that I have just run that for the test, but I don't have yet anything about the data set itself. So I'm going to be happy with that, but that's not enough. I'm going to take this as the new tool. So that's what I'm going to do here. I'm happy with that, but I also need data. That is to say, I will need to fetch data, which is going to be then used to actually invoke that thing. So this is what's going to happen here. I need the latest metrics. So what does it mean? I can always check that. If I do something like the HVAC1 and click a test, I should get the data. Yeah. Now, if I don't, that means I have to feed it a little bit. So let me just do that now quickly. I have it something here. So let's gonna just shoot some data again. So there we go. And if I test it again, now we're gonna see the latest data points. Good. So I'm happy with that one. And now at least I have means to feed the data sets and then execute the test. Now I can also then do something else. I can also do explanation of the rule. What does it actually mean? The LLMs are not causal and they cannot not really understand the logic under the hood. Having said that, there are little tricks you can do to make at least LLM understand the intents which are causal. So what does it mean on Earth, what I just said now? If I take this here, this test that I've done, I'm gonna transform that into the JSON representation of the rule, and I'm gonna ask the question. You are the agent who can ask the question, can answer questions about the rules logic. And here, I'm just gonna say, explain me what I'm actually have designed as the um, as an expert. And what's going to happen now is that in the Slack, I'm going to get an answer about what on earth this rule is all about. So if I now go back into Slack, so this is what's going to happen here. So look at back at bot. What you're going to see is that, okay, that was the thing around the weather before, but now I'm pushing the Slack to answer here. You see that somehow we made LLM models to understand the logic intent of the rules designer. It does say here, if these things are above a threshold, so it combines these things in end relation, it also expects all these conditions to be true above the threshold to fire the problem, and this is the summary of this rule. That's very handy if you, for instance, want to have something like auto remediation. If the tool finds the problem and you want to say, so what's now the remedy for that? So that would be something like this. Let's take, I'm looking for a remedy for the HVAC one, and I say that I have a filter problem. What I want to do is to say, okay, remedy for that would be, for instance, to replace the filter by looking at the manual how to actually do that. What does it mean? If I look back into this thing here and I see there is a problem with the HVAC filter, and I say, what is the remedy for this issue? It's gonna execute a tool that, looking at the type of the HVAC that we have in mind, it's gonna say, well, you know what, this is the page that you have to look for, and then actually look at the repair action. So that was in our world. Just one more rag, if you like. I'm sorry, I'm trying to get here. That was actually used as a tool. So I'm gonna take this remediation, if you like, in my environment as well. That was this guy here, and I'm gonna use that one as well. And I can build so on and so on many different tools. Now then I'm gonna take the role, select one for diagnostic test, and then just basically deploy this as an application. In some of the previous videos I have created such an application, and as you can see here, what I had here, I had like a storytelling, a system prompt, what I'm supposed to do, and look at here. So once you receive the HVAC asset name, call the latest metrics function to retrieve the latest data sets and then pass that to run diagnostic test. And as you can see here, we had all sort of different things. We also had a means to retrieve inventories. Here, for instance, I use a hidden query to query only objects which are for type inventory. I had means to tag to select the HX, do the rule explanation, get remedy, post the Slack message, create a work order, and so forth and so forth. Now let's do the same thing through here. What I'm gonna do now and just say something like list me all HVACs. You know, see this is now, and again let's do the same thing here. I'm gonna have a separate window here, and I'm gonna look here what has happened. So this was the list of all HVACs, and here, I'm sorry, it was actually the old session. So let me go back here. Okay, that's the new one. Yeah. So what you see here, I've got this question from me, and that was the API response. It's kind of long, and then it made out of that this thing back. So again, if you look back here, what I did, I said list me all HVACs. It found a tool that can actually answer that question, went there, did a query, came back with a JSON representation, and then pass it through the LLM back to me. The next thing I can do now is that let's go back to here. I can say, you know, do the diagnostic test for HVAC 1. Now, what's going to happen, and again, it's something that we've seen so far, is that it has to go find the data set for that given HVAC and pass it to the argument to a diagnostic test and run that one. So it executed two tools behind my back, if you like. And if I look here, this is what has happened. Do diagnostic test for HVAC 1. I'm invoking first get latest metrics. I'm getting that as a result. Then I'm invoking this thing. There is no alarm, and that has been sent back. So what it did, it took both responses and sent it back to me. Now, I can also do something else now, and I say so now, something like um, explain me the, so you see here the template that was actually used for a diagnostic test. So what's gonna do now, again, it's gonna invoke the rules explainer. It's gonna take the LLM to interpret that and send me that back, if you like, in plain English. Again, if you look at back here what has happened, so this is the stuff here, is that now we had inside one of the rules or APIs another LLM. It could have been a totally different one, and typically what we do, we fine-tune that LLM with our additional data sets, which include the rules and the outcomes, such that we have a better understanding and answer to what is the intent of the rule itself. So that was what actually happened here. And again, you see here response that actually came back to us. I hope you enjoyed this video. It was a little bit longer, and stay tuned for more. Thank you very much.